Imagine falling for 15 minutes and never landing. Your last messages reach home stretched into whispers, your clock slows to near zero, and the universe behind you curves into a glowing ring. Tonight, we're diving into 10 creepy true facts about black holes, nature's most extreme, most unsettling objects. Buckle up and don't look down. Number 1. You can cross the point of no return without noticing. If you were bold or unlucky enough to drift toward a black hole, nothing dramatic marks the moment you cross the event horizon. There's no wall, no flash, no checkpoint. Locally, you'd feel weightless as you free fall, but globally, you've crossed into a region where every future path points inward. Even beams of light aimed outward are dragged back in. That's why the boundary is called the event horizon. Events inside can never affect the outside universe. NASA's 2024 visualization work shows in eerie detail what that fall would look like. Spiraling light, distorted star fields, and a final sweep into darkness as your view of the universe compresses into a bright, warped ring. The creepy twist? Your friends watching from far away would never see you cross. To them, you slow, dim, and freeze just above the edge. Your signals red-shifted to oblivion. To you, it's a swift drop. To them, you're a ghost that never quite disappears. Number 2, spaghettification is real, and we've watched it happen. Spaghettification sounds like sci-fi, but it's harsh physics. The black hole's gravity is so much stronger at your feet than at your head that it stretches you into a long, thin strand, just like spaghetti. For decades, this was a textbook idea. Then, in 2020, astronomers caught a star in a nearby galaxy being actively shredded by a supermassive black hole. The event, named AT2019 QIZ, sits about 215 million light-years away. Telescopes from the European Southern Observatory watched debris stream outward at up to 10,000 kilometers per second as the black hole's gravity tore the star apart and hurled material in powerful outflows. The team called it death by spaghettification, and, well, it looks exactly like it sounds. Seeing a star stretched to filaments, then swallowed. Creepy. Seeing the afterglow as the black hole burps the leftovers back into space, creepier. Number 3. We photographed the darkness. For a century, black holes lived in equations and indirect clues. Then, on April 10, 2019, the Event Horizon Telescope unveiled the first direct image of a black hole's shadow, M87*, a 6.5 billion solar mass beast in the Virgo cluster. The orange donut, everyone remembers, is hot plasma glowing as it orbits near light speed. The dark center is the shadow cast by the event horizon's photon-trapping gravity. In May 2022, the same global array revealed the first image of our own galaxy's supermassive black hole, Sagittarius A star, about 4 million times the Sun's mass and 27,000 light-years away. The unsettling part, despite a billion-fold mass difference, both black holes look strikingly similar, proof that gravity plays by the same rules at every scale. These images are not CGI. They're the universe itself bent into a ring by extreme gravity. Number 4. A monster is lurking just 2,000 light-years from Earth. Black holes aren't just in distant galaxies, they haunt our own cosmic neighborhood. In April 2024, ESA's Gaia mission revealed BH3, the most massive stellar mass black hole known in the Milky Way, roughly 33 times the Sun's mass and 27,000 light-years away. It's in a wide binary with a normal star, which is how Gaia spotted it by tracking the star's subtle wobble under the black hole's pull. BH3 is quiet. No bright accretion disk, no X-ray fireworks. It's basically invisible until precision measurements give it away. That's the creepy part. The Milky Way likely hides many such dark companions, drifting silently, detectable only when they drift in front of distant starlight, like a shadow you notice only when it crosses the wall.
Number 5. Some black holes roam the galaxy alone, and one passed the eye test. Astronomers have long suspected rogue black holes, stellar remnants kicked loose from their birthplaces, wandering the Milky Way without a companion star to betray them. In 2022, Hubble delivered compelling evidence for at least one such solitary object via gravitational microlensing, an invisible lens that briefly magnified a background star as the compact lens passed in front. Careful measurements of the deflection and the star's apparent motion pointed to a dark lens with several solar masses and no detectable light of its own, a free-floating, stellar mass black hole. That's unsettling, because microlensing is rare. If we caught one by chance, logic says there must be many more roaming the galaxy, totally dark, revealing themselves only when they drift in front of distant starlight, like a shadow you notice only when it crosses the wall.
Number 6. Time itself breaks your intuition near a black hole. Einstein's relativity says gravity and time are entwined. Closer to a massive object, time runs slower. Near a black hole, this effect gets extreme. A clock skimming the event horizon might tick so slowly that hours for you could be years, centuries outside. If you skimmed the edge of a supermassive black hole and returned, ignoring the survivability problem, you'd come home to the far future. NASA's 2024 deep dive on falling into a black hole uses real physics to visualize how your view of the cosmos would distort. Stars smear into arcs. The universe behind you beams into a bright, lensed ring, and the light you try to send outward loses energy, sliding to red, then infrared, then radio. Creepy takeaway? Time and light don't behave near a black hole. They obey. And what they obey is curvature. Number 7. Black holes let you see the back of the disk. There's a mind-bending optical trick near black holes called the photon sphere, a region where light can orbit the hole in precarious, nearly circular paths. It's unstable, but while photons are whipping around, they can loop the hole and escape in our direction. The result? In principle, you can see multiple, lensed images of the accretion disk, including light from the backside of the disk bent over the top. That glowing ring in the EHT images is not the horizon itself, it's light orbiting perilously close to it, boosted and bent by relativity. Even the brightness asymmetry, one side of the ring appearing brighter, comes from relativistic beaming as plasma races towards us on one side and away from us on the other. It's an optical illusion produced by gravity so strong it sculpts the path of light like clay. Creepy and beautiful. Number 8. Black holes ring when they merge, and we've heard it. On September 15, 2015, the twin LIGO detectors felt space-time ripple for the first time. GW150914, the merger of two black holes around 29 and 36 times the sun's mass. The signal rose in pitch, chirp, as the holes spiraled together, then faded as the remnant settled into a single, larger black hole. That last phase is the ring down, where the new black hole vibrates in characteristic quasi-normal modes, the tones of space-time itself. Turn the data into audio and you can literally hear it, a brief, rising blip. Those tones act like fingerprints. Measuring them lets physicists do black hole spectroscopy, testing whether the object's vibrations match Einstein's predictions for a Kerr black hole. They do, so far. The creepy bit is the scale. During a fraction of a second, that merger radiated more energy in gravitational waves than all the stars in the observable universe emit at light at that instant, and Earth felt it as a distortion smaller than a proton. Number 9. They do evaporate, but on timescales that haunt the far future. Black holes aren't truly eternal. Thanks to quantum effects near the horizon, they slowly leak energy in the form of Hawking radiation. The bigger the black hole, the slower the leak. For one solar mass black hole, the evaporation time is on the order of 10 to the 67th years, a 1 followed by 67 zeros. Supermassive black holes last far longer. By comparison, the universe today is only roughly 1.38 times 10 to the 10th years old. What's creepy is not tomorrow's danger, it's the cosmic solitude this implies. In unimaginably distant eras, when stars have burned out and galaxies have faded, the last fireworks will be black holes whispering their energy away into the cold. Numbers this large are hard to grasp, but the math is standard and the conclusion is stark. In the endgame of the universe, black holes are the final lights to go out. Number 10. Black holes shape entire galaxies, and they may come in missing sizes. Black holes aren't just cosmic garbage disposals, they're architects. Observations with NASA's Chandra X-ray Observatory and other telescopes show that supermassive black holes can pump energy into their surroundings via jets and winds, regulating star formation in their host galaxies. In galaxy clusters, this feedback can keep hot gas from cooling, slowing down the birth of new stars. The black hole and its galaxy grow together and keep each other in check, like a thermostat for cosmic cities. Even stranger, there's a long-standing gap in black hole sizes. We know stellar mass black holes, a few to a few dozen suns, and supermassive black holes, millions to billions of suns. Intermediate mass black holes, tens of thousands of solar masses, are rare and hard to confirm. But in July 2024, Hubble found strong evidence for a hidden one near the core of the massive star cluster Omega Centauri. Catching these middleweights helps explain how baby black holes grow up into the giants we see in galaxies today. The idea that a mid-sized black hole is quietly cruising inside a dense star city in our own galaxy? Deliciously unsettling. So what makes black holes so creepy? It's not just that they're powerful, it's that they warp the rules. Up becomes in, light becomes trapped, time loses its grip. We've seen their shadows, we've heard of their mergers, we've watched stars get shredded, we've found silent ones hiding next door, we've even mapped how they regulate the growth of galactic metropolises. And somewhere out there, maybe many somewheres, a black hole is roaming, dark and alone, waiting for a random star to wander across its path. If this blew your mind, hit like so the algorithm doesn't toss this into a gravitational well, and subscribe for more deep space chills. Drop a comment. Which fact creeped you out the most? The spaghettification, the time dilation, or the rogue loner drifting through the Milky Way? Thanks for watching, and I'll see you in the next one, hopefully outside any event horizons.